Greeting respected lecturer Mr. Aiming Chun. We are very delighted to present about our final database group project today. This project is complete by 5 members, Maunari, Amlin Sopari, Chichanika, Moniko Satine, and myself, Chitus Kunkeo. This is our table of content. We have 5 main points, 1 introduction, 2 database partitioning, 3 transaction, 4 stored procedures, and 5 demonstrations. So what is our project about? Our project is about the hotel management system. Okay, so what is the hotel management system about? So the hotel management system is designed to manage a hotel operation that include rooms, customer, booking, payment, and review. But for our project, we mainly focus on the booking. In this project, we explore on 3 advanced database techniques, such as database partitioning, transactions, and store procedures. We use these to improve the query performance and maintain the data consistency. In our project, we have 6 key features. Hotel management that maintain the information about the hotel, including the name, address, and the locations. Room management, which track the room availability, the type, the capacities, and the price overnight. And then customer management, which store the customer profile, email, phone number, contact detail, booking history, and then for the booking operation, which facilitate the room reservations, including check-in and check-out management, and then payment processing, which record and track the payment, including the status of the payment and the method that the customer used to pay us. And last but not least is the customer review, which collect the feedback, the rating, and they can comment to improve our service quality. In our project, we have 2 database design, entity relationship diagrams, EOD, and the relational model, or so this is our entity relationship diagram. We have 7 entity. We have customer, booking, hotel, review, payment, room, and room type. So now let's start with the customer. For the customer, we put the contact details like customer phone, customer name, customer ID, customer password, customer email, and for the customer, they make the booking. So they make the booking. So the booking have the room ID, have the hotel ID, have the check-in and check-out, and have the customer ID. And for the booking, they can book a room. So the room, they store the information about the room ID, the room status, the room capacities, and the price. And inside the room, we have the room type. So the room type is like a weak entity because it depends on the room. So the room type in here we put because we want our customers to choose what kind of room they want, like such as luxury, or they want a classic, or they want the normal one. And in the room type, we have the room type name, the room type descriptions, the room type ID. So the room is also inside the hotel. And the hotel, it have the hotel address, hotel ID, hotel name, hotel city. And for the booking, one booking belong to one payment, and the payment informations the payment entity have information like payment date, payment ID, booking ID, payment status, amount, and payment method. And for the customer can review the hotel. So in the review, they have the customer ID, the hotel ID, and then the review ID, rating, review date, and comment. This is our relational model. So for our relational model, we just convert the entity relationship diagram into the table with a primary key and foreign key. I will now hand over to my teammate to continue the next section.
So creating our lecturer, Mr. Anmin Chung, I'm Tida. So in this part, we're gonna talk about the data partitioning. So what happens when the data in your database gets too big to fit on one machine, or you need to support very high query throughput numbers. It's clear that as we grow our system to more data and more query per second, you need to somehow adapt and scale the database to handle this increased load. So the solution for this is partitioning, and partitioning is the process of breaking up a database into multiple pages, which are called partitions. Moving to the next part is why and when should we do database partitioning. So let's take a look at the why first. So first of all, it's improved availability. Whenever you are separating the data across multiple servers, it's avoid any single points of failure. If one instead fail, only the data in that partition is unavailable, and operation on the other partitions can continue. Next is improve performance and improve scalability, increase security. And when should you do it? So when your table is too large, yes, you should partitions them into smaller database. And when it is blocking reader and writer because your database is too large, and scaling multi tenants and tuning query. Now let's take a look at methods of data partitioning. So the first method, and that is the most famous method, is horizontal partitioning. So horizontal partitioning means splitting a table by rows. Here the same table structure is kept, but different records are stored in different partitions. For example, user are divided into multiple tables, each holding a subset of rows. So for the advantage, it is simple, and all partitions have the same schema as the original database, and so it's easily to implement and understand. However, there are drawbacks. There can be unevenly distributed, and one partitions may receive much more traffic than others, leading to performance imbalance. For the second method is vertical partitioning. It split a table by column instead of rows, and different attributes of the same entity are stored in separate partitions. For example, like product detail, like name, description, price, are separated from stock, and that's information. The benefits are that it's straightforward and allows storing different types of data separately, which can improve performance for specific queries. And on the other hand, as data grows, additional partitioning may be needed. Also, queries that require data from multiple partitions need joins, which can be expensive and slow. So moving next to the next part is partitioning criteria. There are five. So the first is round robin partitioning. It distributes record evenly across partitions in a rotating order without considering any specific key. Its main goal is load balancing. For example, there are a database and it divides into three partitioning. So the data will go to partition 1, partition 2, partition 3, and then repeat it. So the second is list partitioning. So it's divided based on a predefined list of value. Each partitions contain rows that match a specific value. So for example, a customer table is partitioned by country, where one partition stores USA and another store India. Third is hash-based partitioning. So it uses a hash functions on a partition key to determine where data is stored. This helps attribute data evenly and avoid hotspots. For example, user records are assigned to partitions using hash, ensuring balanced storage. And for the fourth is range-based partitioning. It split data according to a range of value, and it is commonly used for time-based or numeric data. So last but not least point is composite partitioning. So it combines two or more partitioning methods for better control and performance. It is useful for very large and complex data sets. For example, a table is first range partitioned by age, and then hash partitioned by country.
So transaction. What is transaction? Transaction is a set of SQL operations executed together following ACID property, which is A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. So this is how the transaction work. First, the transaction begin. After that, all of the database operations inside the transaction are executed. If all the operations are completed successfully, the transaction is committed. This means that changes are saved permanently in the database. If any error occurs during the process, the transaction is rolled back. This means all the changes are undone and the database returns to its previous state. This is the ACID property, so it have automaticity, consistency, isolation, and durability. So what is automaticity? Well, automaticity means that all the operation in the transaction must be completed successfully. If one operation fails, the entire transaction fails. Example, in a bank transfer, if money is debited from the account, the entire transaction should be failed or cancelled. What about consistency? Well, consistency ensures that a transaction brings the database from one consistent state to another, maintaining all the predefined rules and constraints. Example, if there a constraint that account balance cannot be negative, a transaction should never violate this rule. What about isolation? Isolation means that the multiple transactions can be run at the same time without affecting each other. For example, two transactions trying to update the same account balance at the same time should not impact each other. And for durability, that it guarantees that once a transaction is committed, the changes will remain safe even if there is a system fail. For example, once a bank transaction is successful, the updated balance should be safe even if the system crashes immediately afterward. And this is the pro and con of the transaction. Let's take a look at the pro first. So it ensures that the data reliability and consistency, enable error recovery while rollback, and manages concurrency safely. And for the cons, can lead to performance overhead, especially under high concurrency, require careful log management to avoid deadlocks, misuse. Example, long-running transactions can cause blocking and reduce throughput.
So let's move to our next part is about store procedure. What is store procedure and why we need it? Store procedure are block of actual codes that store in the database and can execute whenever needed. We no need to create it again and again. We just call it like, for example, it's like function that we just call it when we want to edit tasks, select a task, or do something else. And this is the pictures of store procedure. Yes, store procedure is like function, but it can do many things like read, insert, update, and delete. What are the benefits of using store procedure? Yes, using store procedures have a lot of benefits. Like the first one is for performance, is pre-compiled and automated. Store procedures run faster because database prepares them in advance. Database already know how to run the code, so it does not need to think again every time. We just call it and we can use it. And second is security. It's control access at the procedure levels. Like user can run the store procedure without changing the table data. And this helps protect important data and prevent user from changing data directly. Third, code reuse. Yeah, we only write once. We don't need to write many times. So our actual code one time and use our actual code need to write only one time, and when we use it, we just call it. And fourth, maintainability. Yes, it is easy to update because when we want to change, we just update store procedure by like call the function that we have created to update or do something here. And the last one is network traffic because like instead of sending many actual commands from application to data, the application just send one procedure call. Yes, like I have mentioned, store procedure we just call it to use, not like have to write many commands again and again. So the last point is about demonstration. So we will show you how we apply all these techniques to our project called hotel management system that or hotel booking system. So let's see together. Hello teacher, welcome to our demonstration video. And you see our database named Booking Hotel DB. In our database, we have table like room, payment, customer, booking,
and more. So now I'm going to show you about partitioning that we have applied on our project. For partitioning, we have applied on booking, payment, and review. We use it to make it easy and faster when we want to execute a code like select or something else. So now let's move to the next part, is about transaction. For transaction, we have example already applied on booking partition, and I will show you that it is success or not. So let's see together. So we select from booking to know that the data we have input in our table or not, to know that the transaction is success or unsuccess. And this is data that we have insert. Last but not least is about store procedure. We have 7 procedure like add booking, get customer total price, add payment, check room available, get hotel totals, and more. For add booking, it's not work anymore because I have run it before. Get customer total price is about like customers booking for 3 or 2 days, it totals in this function. For next function is about payment. Yes, it's not works anymore because I ran it already. But we can test that our payment is added or not by showing the tables of payment, and this is the payment ID that we have added. And the function is about check room available, and we see that booking count is 2. That means this room is not available. If it is available, the value will be 0. The next one is about getting hotel total. This means like how much that hotel earn from booking. Next, customer total is about how much they paid. The last one is booking totals of booking ID 3. So the results of our demonstration. Thank you for your attention, listening, and watching our video.